Okay, so differentiation. When you're differentiating, you have trig functions, yeah? So let's create a little table here. Y and then dy dx. Okay, so you got three main ones. You got sine, cos, and tan. Okay, so sine, when you differentiate it, becomes cos. Cos, when you differentiate it, becomes minus sine. And then tan becomes sec. This is on the data sheet. I think on the data sheet it's written that tan, or k tan x, is equal to k sec x. That's sec squared. So sine is cos, cos is minus sine, and tan is sec squared. And this is the only one on the data sheet. These two you have to memorize. Okay, so if I was doing an example, let's have y is equal to 5 sine x minus 4 cos x. So it's already as basic as we can get it, so let's differentiate dy. Okay, so if we're differentiating 5 sine x, well, sine becomes cos, that becomes 5 cos x. And then if we differentiate 4 cos x, well, that then becomes minus 4 sine x. So then with the minus sign there, that becomes plus 4 sine x. If we did another example, let's have a look. Y is equal to the root of 16 minus 16 sine squared x. Now, you can't just separate this into root 16 minus root 16 sine squared x. No, because that's like, you can't, it's like saying that, let's get a different color pen. It's like saying that a plus b is equal, well, is not equal to a squared plus b squared. You can't do that. So what we are going to do is we're going to factor out a root 16. Okay, so that's going to become y is equal to root 16 lots of 1 minus sine squared x. And well, what do you notice about this here? That is a trig identity. Cos squared x plus sine squared x equals 1. So that is also then equal to root 16 upon cos x, because it's the root of cos squared x, which is also then equal to root 16, well, that's just 4, isn't it? 4 cos x. And then we go to our table. Well, cos x becomes minus sine. So if we dy dx, that becomes minus 4 sine x. Easy peasy. Okay, now sometimes you might have to throw in an e number or a ln function. So let's do a question here. Let's say y is equal to 2e to the x minus sine x, and I want to find the normal to the curve at the point 0, 2. Right, so what do we know about normals to curves? Well, a tangent has the same gradient, is the gradient. The normal is the inverse gradient. Oh, the negative reciprocal, sorry, yeah, that's what I meant to say, sorry. So, well, we can just do this straight away. Dy dx, because when you differentiate, you find the gradient, right? So that becomes, well, when you're differentiating e, keep the e power, the x power the same, and then multiply it by the power. So that just becomes 2ex. And then minus sine, well, sine to cos, so then it becomes minus cos x. Okay, so x is equal to 1, so we're going to say at x is equal to 0, so x is equal to 0. We're going to say 2e to the 0 minus cos 0. Well, that's 1 minus, where's my calculator? Sorry. Calculator's gone for a walk. Oh, sorry, that's 2, because that's anything to the power of 0 is 1, right? So that's going to be 2 times 1 is 1, minus 1 becomes 1. And then we're going to take the negative reciprocal of that. So that then becomes, well, minus 1 over 1. Okay, so we've got our gradient of the graph. It's going to be, so we'll plug that into y equals mx plus c. So we're going to say that y is equal to minus 1 plus c, 1x, sorry. And let's plug in 2 because that's our y value. So 2 is equal to minus 1 lots of 0 plus c. So then c is equal to 2 because you get rid of that. So our formula for that, for the normal to the line at this point here, so y is equal to minus 1x plus 2. And that is our answer. That's the easy part. What we're going to do now is something called the product rule. So the product rule is like this. So let's say y is equal to u times v. Okay, so basically it's when there's two functions multiplied with each other. Okay, so the formula, let's say if, so then dy dx is equal to u dv dx plus v du dx. That is your formula, and you need to have that memorized because that's not on the formula sheet. Okay, so let's do an example. Let's say y is equal to 2x sine x. Okay, so we can clearly see there's two things multiplied with each other here. So we're going to say u is equal to 2x and v is equal to sine x. Okay, and then we're going to find du dx. Well, the differentiator of 2x, that's just 2, isn't it? And then dv dx, my v's can look like u sometimes, you're going to have to deal with it. Dv dx, well, sine x, if we go back to this side, sine x becomes cos x, doesn't it? It becomes cos x. So we're going to find dy dx. Well, let's use our formula. So u times dv dx, so that becomes 2x cos x plus v du dx. Okay, so this becomes sine x times 2. It becomes 2 sine x. And that's your answer. Okay, we'll do another example with an e number. So if I set y is equal to 2x e to the x, well, you can see that u is going to be equal to 2x and v is equal to e to the x. So u is equal to 2x, v is equal to e to the x. Okay, so du dx, well, that's going to equal to 2 again, and dv, I'm going to try my best to make them look like u's. dv dx, well, that's going to equal, keep the x power the same, and then multiply by the differentiate of the power. Well, that's just going to be 1, so that's going to be e to the x. Okay, so we got our u's, we got our v's, we got our du's, dx's, and our dv dx's. So let's find dy dx then. So using the formula, u times dv dx is 2x times e to the x. That becomes 2x e to the x plus v times du dx becomes e to the x times 2. That becomes 2e to the x. And then you can probably factor that out. That becomes 2e to the x, lots of x, plus 1. And that's your answer. And then you can do that with lins, and you can do that with anything, essentially. Now, the other thing that you have to learn is the quotient rule. And the quotient rule is exactly, that's quotient rule. It's exactly the same as the product rule, but it's for dividing. So we're going to say if y is equal to u over v, then dy dx is going to be equal to v du over dx minus u dv over dx all over v squared. So it's a bit longer, but again, you have to memorize it. It's not on the formula sheet. So EG1. So let's say y is equal to 2x over sine x. Okay, so v is equal to, u, because you have to keep it this way. The same with the last one. It's probably best if you just keep it as if the first term is your u and your second term is your v. It doesn't overly matter for the product rule, but it does matter for the quotient rule. So I'm going to say u is equal to 2x, v is equal to sine x. So then du dx is going to be equal to, well, the differentiate of 2x, that's just 2, and dv dx, that's just going to be equal to cos x. So if we use our formula then, dy dx, v times du dx, so that's going to be sine x times 2, that's going to be 2 sine x minus u, well that's 2x, and dv dx is cos x, so that's going to be 2x cos x all over v squared, so that's going to be sine squared x. And then we can simplify that. That can be 2 sine x over sine squared x minus 2x cos 2x cos x over sine squared x. And then, well, that is going to cancel with that. And cos over sine is cot, right? So we can also write that as, right here, 2 over sine x minus 2x cos x over sine x sine x. And cos over sine is cot, so that's going to be equal to 2 over sine x minus 2x sorry, that's 2x cosec x times cot x, which then simplifies to 2 cosec x upon 1 minus x cot x. That's just simpling it out. Really, your answer is that part, but if it asks for it in its simplest form, that is your answer there. Okay, we'll do another example because that one might have been a little bit harder to follow. Let's try this one. Okay, y is equal to tan x over x squared. Well, u is going to be equal to tan x. V is going to be equal to x squared. Du dx is going to be equal to sec squared x. Let's remember, we go back to our rules. And then dv is going to be equal to 2x. So let's use our formula again. Dy dx, well, that's going to be equal to v du dx minus u dv dx all over v squared. Okay, so we'll plug that in. X squared times sec squared x minus tan x, 2x tan x, all over x squared squared. It's going to be x to the 4. And then you can simplify that. You can take an x out of that because there's an x positive to all these terms. So that's going to be x, lots of x, sec squared x minus 2 tan x all over x to the 4. And then again, you can simplify that. You can cross that off and cross that off. And that becomes sec squared x minus 2 tan x over x to the 3. Problem solved. And those are two things you just need to know there. Your quotient rule, your product rule, and where's it gone? The quotient rule, the product rule, and your differentiation laws. Easy peasy.